In this video, I want to talk to you about how we simplify radicals, including algebraic expressions in the radicand. And I'm going to start with a simple example. To find the square root, I'm going to use the product rule here, and I can think of some factors of 12 are 4 and 3. And the factors of x to the fourth, well, know that x to the fourth is just equal to x times x times x times x. So I'm going to list the products that make x to the fourth like that. And I know the square root of 4 is 2, so this guy I'm just thinking is 2. The square root of x times the square root of x is going to be, that'll just make x, and the square root of x times the square root of x will just make x here. So I'll have 2 times the square root of 3 times x, and we usually write the non-radical parts of the answer first, so this is going to be 2x times x is x squared, and the radical at the end. 2x squared times the square root of 3 is the square root of 12x to the fourth. Okay, well, there are a couple rules you need to know when you're simplifying algebraic expressions, and the biggest one is that the answer always has to be positive, right? We said that this radical always indicates the positive root. Well, with numbers like the square root of 24, when we say that the simplest form of the square root of 24 is 2 root 6, it's easy to tell this is positive. 2 is positive times the square root of 6, which is positive. That gives us a positive answer. It's harder with expressions that include variables because the variables could be any number. So if I put, let's say, -5 in for x, will the answer here be positive? And what if I put in a positive number? What if I say x is positive? Will it still be positive? Well, let's just try that really quick. Is it going to be, if I do 2 times -5 squared times the square root of 3, will I get a positive answer? And in this case I will, because the square root of -5 squared is a positive number. This will just be 2 times 25 times the square root of 3. By the same token, if I put a positive number in here and I square it, my answer will be positive. So 2, which is positive, times a positive, will give me all positive answers. What if I tried to find the square root, though, of 12x to the second? Well, I could factor 12 as 2 times 2 times 3, and x to the second as x times x. And I get a pair of 2's from 12. That makes positive 2 times the square root of 3. And there's a pair of x's here, which just makes x. So I get 2x times the square root of 3. Well, if I have to make sure this is positive, this expression by itself doesn't guarantee that. If I put a negative number in here for x, then this expression will be positive 2 times a negative times a positive, and that's equal to a negative. So in order to ensure that this is a positive root, I have to use absolute value and put absolute values around the variable here. So in order to simplify any algebraic expression, you need to understand that if a variable from under the radical shifts from being even inside the radical to being odd outside, in this case, x to the second became, under the radical, was able to be converted into x to the first. When the variable shifts from an even power to an odd power, you have to use the absolute value around that variable. If you have multiple variables, you might as well group them all in the same absolute value. Let's see another example. Let's say I had the square root of 20 x to the fourth, y to the sixth, z to the eighth, a to the 10th. Well, you might start to realize that I can do some of this a little bit faster. I can see some patterns in the square roots that will help. 20 can be simplified as 4 times 5. And x to the fourth is going to be x times x, 4 times the y's, they're going to be 6's, or 6 y's. There'll be 8 z's and 10 a's. Well, let's start to think about those. I'm going to get the square root of 4 is just, I can think of that as 2. So I'm going to have 2 times the square root of 5. There's going to be 4 x's, so there'll be 2 groups of x. That'll be x times x, or x squared. 6 y's, which makes 3 groups of y. So I'm going to have times y to the third. 8 z's, so there's going to be 4 groups of z. Z to the fourth. 10 a's, so 5 groups of a times a to the fifth. Okay, well, some of these variables went from even inside to odd. Let's see which ones they were. Y was 6 in the radical, and now it's to the third power outside. And a was to the 10th, and now it's to the 5th. So to write the expression, I'm going to simplify this finally as 2 x squared z to the fourth times the absolute value of y to the third a to the fifth times the square root of 5. Whoosh. That seems really complicated. If you watch the other video, it should make sense to you that how we simplify the square roots. And all I'm adding here is an absolute value when a variable goes from even inside to odd outside to make sure that my answer is still the positive root.